Welcome learners. This is lecture on partition values and coefficient of dispersion. From this lecture, we will be able to learn the different partition values like quartiles, percentiles, deciles, and various coefficient of dispersions. And these are the absolute measures of dispersion and the coefficient of variation for comparing two groups. Okay, before going to the partition values, let us look at what is raw data, discrete data and continuous frequency data. This is raw data, x1, x2, xn, xn minus 1 and xn. This is raw data, and this is discrete frequency distribution. Here this is the value of variable, and the frequency, number of times the variable occurs, is called frequency. And we arrange the raw data in the form of class intervals and tally marks, and this is cumulative frequency. This cumulative frequency is calculated as f1, f1 plus f2, f1 plus f2 plus f3 up to fn plus f2, fn. Total frequency must be equal to sigma fi, that is equal to capital N. Okay, now we will discuss the partition values. The partition values are also called quantiles, or the values of variable which divide the data arranged or ordered data into equal parts are called partition values or quantiles. More frequently used partition values are quartiles, deciles and percentiles. First, let us discuss the quartiles. There are three values which divides the data into four equal parts and called quartiles. These quartiles are denoted by Q1, Q2, Q3. Q1 is the first quartile, Q2 is the second quartile, Q3 is the third quartile. Similarly, deciles are the 9 values which divides data into 10 equal parts. They are called deciles. They are denoted by D1, D2 up to D9. Percentiles are 99 values which divides the data into 100 equal parts, and they are called percentiles. They are denoted by P1, P2 up to P99. The computation of partition values are, we will discuss in case of raw data and in case of discrete data and continuous data separately. Suppose a data contains n values, say x1, x2, xn, arrange data into either ascending order or descending order. The partition values can be defined as follows. If n is odd number, there are two ways of calculating these partition values, in case of odd and in case of even. In case of the value of n is odd, and the procedure is, this is the quartiles. The first quartile is the value of the variable corresponds to n plus 1 by 4th term value. Okay, and similarly deciles are n plus 1 by 10th term value. We arrange them just to this n plus 1 by 12th term value is, in case of raw data, D1 value. Similarly, percentiles are, P1 is the n plus 1 by 10th term value is called nth percentile. The first percentile, n plus 1 by 100. Similarly, Q2 is 2 into n plus 1 by 4th term value. D2 is 2 into n plus 1 by 10th term value. P2 is 2 into n plus 1 by 100th term value. Similarly, the quartile Q3 is 3 into n plus 1 by 4th term value. D9 is 9 into n plus 9 by 10th term value. Here is 99 into n plus 1 by n 100 term value. Here n is the number of variables. Here is total number of values. In case of n is even number, it is next to n by fourth term value q1. q2 is 2n by fourth term value next to corresponding to that value. q3 is next to 3n by fourth term value. Similarly, deciles are n by 10th. Percentiles are n by 100th. Okay. In case of even, we just do the next to the n by fourth term. Next to d2 is 2n by 10th term value. Okay, this is for raw data. And in case of discrete frequency distribution, first construct a less than cumulative frequency table for the given data. The partition values are defined as the value of the variable correspond to the less than cumulative frequency just greater than n by fourth value in case of first quartile. In case of second quartile, just greater than 2n by fourth term value in cumulative frequency. This is also first we calculate the total sum of all values, that is n by 4 we calculate in cumulative frequency n corresponding to just greater than n by fourth term value gives us the first quartile. Similarly, the deciles also. D1 is cumulative frequency just greater than n by fourth term value. In case of discrete frequency, we have in discrete frequency we have x variable and f only. Okay, we calculate cumulative frequency and the term corresponds to just greater than cumulative frequency value gives us the different quartiles, deciles and percentiles. In case of continuous frequency distribution, these in case of raw data and discrete data, directly we can get the percentiles, the partition values. Whereas in continuous frequency distribution, we use the formula. Consider the less than cumulative frequency table for the given continuous frequency distribution, then identify quartile classes, decile classes and percentile classes as follows. The first quartile class is the class corresponding to less than cumulative frequency just greater than n by 4 value. Q2 class is the class corresponding to less than cumulative frequency just greater than n by 4 or n by 2 value. Q2 is nothing but median. And Q3 is the class corresponding to less than cumulative frequency just greater than 3n by 4th value. Similarly, deciles also n by 4th value, 2n by 10th value, 9n by 10th value. In case of percentiles, n by 100th value, 2n by 100th value, 99n by 100th value. Here n is the total frequency. Here with usual notation, the formulas are, this is the formula for first quartile, L1 plus n by 4 minus m1 by f1 into c1. Here L1 is the lower limit of first quartile class, n is the total frequency, m1 is the cumulative frequency of cumulative frequency just before the first quartile class, f1 is the frequency of first quartile class, c1 is the class interval of first quartile. Similarly, we can define all these L1s, L9, L1, L2, L99, this M1, M2s, Cs. Okay. Should be noted that Q2 is equal to D5 is equal to P50 is equal to median. Similarly, Q3 is equal to P25. Q3 is equal to P75. We can use the partition values to compute coefficient of skewness and coefficient of kurtosis also. Kelly suggested this coefficient of skewness based on percentiles, and this is given by SK. K. The K refers for Kelly's. P90 plus P10 divided by 2 minus P50. This is also given by P90 plus P10 2 into P50 divided by 2. This measure is rarely used. This is the measure of skewness based on percentiles. Similarly, there is another measure based on, there is coefficient of kurtosis based on percentiles. Here, Kelly, this measure also suggested by Kelly. Kelly given a measure of kurtosis based on percentiles. Here, this beta 2 is equal to Q by P90 minus P10. Q is nothing but quartile deviation. Q3 minus Q1 by 2. P10 is the 10th percentile. P90 is the 90th percentile. Here, this P75 minus P25, Q3 minus Q1 divided by 2, nothing but quartile deviation into P90 minus P10. If this Kelly's coefficient of skewness greater than 0.26315, the distribution is platy-Kurtic. Beta 2 is less than 0.26315, the distribution is leptokurtic. Beta 2 is equal to 0.26315, this distribution is mesokurtic. We have already studied the different types of kurtosis. This is more peaked curve than normal curve is called leptokurtic. The normal curve is called mesokurtic, and the less peaked curve than normal is called platykurtic. Concept is coefficient of dispersion. So far, we have already discussed in the previous lectures the measures of dispersion. The measures of dispersions are absolute measures. They are not used directly for comparing the variations in two or more series of data with different units. Some groups may have in inches, in some groups may have in centimeters in case of height measurement. So we cannot directly compare the measures. The following are some of the relative measures to compare different units of measurements. Here, these are the coefficient of dispersion, which are pure numbers independent of units of measurement. Here, coefficient of dispersion based on range is maximum value minus minimum value by maximum value plus minimum value. Whereas the formula for range is maximum value minus minimum value. Here coefficient of range is maximum minus minimum by maximum plus. Similarly, coefficient of dispersion based on quartile deviation is Q3 minus Q1 by Q3 plus Q1, whereas formula for quartile deviation is Q3 minus Q1 by 2. Here Q1 is the first quartile, Q3 is the third quartile. And coefficient of dispersion based on mean deviation is mean deviation about average, mean deviation divided by average from which it is calculated. We can calculate mean deviation by using an arbitrary value or by using either mean, median or mode. Here the mean deviation divided by the average from which it is calculated gives us coefficient of dispersion based on mean deviation. We have MD by AM or MD by median or MD by mode is coefficient of dispersion based on mean deviation. Here the coefficient of dispersion based upon standard deviation is nothing but standard deviation divided by mean, sigma by x bar. If we multiply this coefficient of standard deviation with 100, we can get a value called coefficient of variation. It is a relative measure of dispersion. This concept was first suggested by Professor Carl Pearson. For comparing the variability of two or more series, we calculate the coefficient of variations for each series. The CV is defined as 100 times the coefficient of dispersion, sigma by x bar into 100. In other words, CV is the percentage variation in the mean, standard deviation being considered as the total variation in the mean. The data with lesser coefficient of variation is known as the consistent data or homogeneous data or data with less variation. The data with greater CV is known as inconsistent data or heterogeneous data or data with more variation. This is about coefficient of dispersion. From this lecture, we learn about the different partition values, quartiles, deciles and percentiles, also different coefficient of dispersion based on range, quartile deviation, mean deviation, and standard deviation. Also, we learned about the coefficient of variation.